All right, we're recording. Thanks, Jason. Thanks, Steyn, for taking another late night out so we can talk a bit about Excel. The idea tonight is that we're going to talk about Steyn's case from the weekend's finals of the South African Excel Championship. The case was called Steyn City, very apt. And I'm just going to quickly share my screen so that we can talk about the case itself. So essentially, due to the rapid growth of Steyn City, the power production couldn't keep up with the power consumption, and therefore the city decided that they had to introduce load shedding. So load shedding is an actual South African concept. To those of you that are not South Africans, essentially what happens is they switch off random areas throughout or not so random, but they switch off areas around the city, switch off the power to sort of reduce the load on the power network or the power grid. And essentially, Steyn's case revolves around each of these neighborhoods. We've got a map. So Steyn used the map, and this map is similar to a previous case, I think from the Microsoft Excel World Championship, I believe. I think it was the 2022 World Championship that had this case. I can't remember I don't know if you guys remember which case exactly it was. Was it Excelopolis, perhaps? Can't remember.
No, it's not that one, but it was used twice. I think once was in Excel game and once was a level in one of the modeling sessions.
Okay, so essentially you've got various cells, and they were so nice to give you sort of the A to or the column names in there, as well as the row numbers. It wasn't necessary for this case in the end. And then you have cars, you've got roads in between the neighborhoods. Each neighborhood essentially has different sort of symbols. So every block represents a symbol in the neighborhood. And this would, for instance, mean a park. This would be a factory or a plant. This would be a residential house. This would be a lake, etc. And each one of those essentially has a different consumption during morning, midday, afternoon, night. And then essentially the questions revolve around that. Then finally, you've got what they call a schedule. So this is my sort of finalized model, but the schedule basically gives you an 11-day schedule for morning, afternoon, evening, night, and essentially tells you which neighborhoods are without power. So this is used in question 5. And then basically you have your residential house. So you've got the icons essentially that represents each of these types of buildings, and you have your consumption. Some of them have a higher consumption during the morning as opposed to afternoon, as opposed to evening, as opposed to night. Night would be typically, let's say midnight to 6 a.m. So that would be the lowest consumption overall for most of them, except for a hospital, which still has high consumption during the nighttime. So very logical question. So this is something you can typically apply to a real world scenario as well. But this was done for a sort of fun case that was proudly South African. I wouldn't say so proudly, but it's very typically South African. And then essentially questions 3 to 5, hospitals and schools are exempt from any power cuts. So that's essentially the sort of synopsis of the case. So maybe Jason, you can take us through level 1 to 3 and maybe tell us what you did. Sort of started off very typical, very easy, and then sort of ramped up to become more and more difficult as the case went along. So maybe you can steal the share or take the share and tell us what you did.
Yeah, cool. Thanks, Renier. Let me pull up my screen. But as sort of similar to last night, I've got very much the working version of my my model open, the one that we used for testing before it looked all neat and tidy. So apologies if things are slightly different places, but the concepts I think will carry through. Actually, level 1 I can probably do here. So level 1 was actually fairly straightforward. I guess just getting you into the mindset that you can do counts using icons in Excel again. So Renier, you mentioned you've got these icons, and essentially what we wanted to just figure out how many of each of these units were in the city. We were given that map that you explained. So my starting point was to just name this range map. So I just called it map, so I could refer to it fairly easily down the line. And level 1 to me, was as simple as saying count if in the map range that icon, and copying that down. So should have been fairly quick marks, I think. But for those who haven't used icons before, good to know that you can use icons as criteria for lookup functions and things like that. And that was really helpful in a mindset going forward.
So if it's interesting to you, I did exactly the same. So my map is also called map, and I used exactly the same formula. So yeah, that is most probably the quickest and easiest way to do it. Steyn, did you follow a different methodology there?
Well, I just didn't rename the map at that stage of the point, so it just manually referred to it. But later my maps are named.
Cool. I guess that's level 1.
Yeah, level 1, quick and easy. Level 2, I'm going to go back to my sort of rough workings. Level 2, and Renier, you said you sort of start simple and then ramps up. And to me, it started really simple and ramped up really quickly. So level 2, I think if you haven't done a case like this before, level 2 would have been really tricky to get right, or really time consuming to get right. And so the question for level 2 was to calculate what the consumption is for a particular neighborhood during the morning period. And so if you go to the map again, you can see that each of these neighborhoods are numbered. This is neighborhood 1, this is neighborhood 2. But to try and put this into some sort of structured data set that you can reference the size of neighborhood 1 and neighborhood 2, because they're different scales. Some are narrow, some are wide. How do you even tackle something like that? And I think to try and write a formula that referenced this map range, that then figured out whether the 1 was in the right place or not, that would have been a nightmare to try and debug in your own mind. But something that I guess those of us who've seen a similar case before, you sort of you make a call in these competitions about where you just do something manually for the sake of setting it up and taking you forward. And so where's my map? Map number 3. So I just created a couple of duplicates of the map, and so that the layout was exactly the same. The map was in the exact same position on each of the tabs. And map number 3, my map 3 tab, the third copy, was I literally went manually and just highlighted. I deleted all the icons in the neighborhoods, highlighted the range, typed in 1, highlighted the range, typed in 2, highlighted the range, typed in 3. And this feels like quite a manual process up front, but it probably 31 neighborhoods probably took 2 minutes, I suppose, to do. But that then unlocked a really simple solution from a formula perspective going forward, as opposed to trying to work out a really complicated formula. And so I guess you got to figure out the balance between those two objectives. And then similarly for the second copy of the map, I went and looked up the icon and its corresponding power consumption in this table that was given. And so I basically had copies of the map with the icon, the original map that we were given, then the map with the power consumption, for the icon. So this is looking back up to the map and then using that usage table to return the consumption. And so then I had the consumption per unit in the layout of the neighborhood, and then map 3 was just the neighborhood number. And so those sort of building blocks then meant that I could take any neighborhood and basically do a sum if on the neighborhood number back to the map number trying to think now. Yeah, neighbors A, I think, was map number 3, was this range over here. Where's neighbors A? Neighbors A. Yeah, same range. So neighbors A was this range where the actual neighborhoods were numbered. And so, I could do a sum if based on neighbors A for the neighborhood that was given in the question. And then the sum range was my map, JW, where I had the consumption values sort of populated. And so working across copies of the map with different characteristics in each of the cells meant that you could build much more simple formulas, doing a sum if, and because the layout was the same, you could easily just apply as if it was the same range. And so, I don't know if that was a bit of a long-winded answer, but that sort of mentality was very helpful and is a great, is a great tip that I've learned over time with these kinds of questions, is to actually tackle some things manually just to help you set up to make things easier going forward. I don't know if you guys want to add anything to that thinking before we go to level 3.
Yeah. I mean, if I can quickly steal a share and just show what I did. I followed a different approach, similar in some fashions, but a bit more different. I worked a lot neater in a sense where I kept my one map, and I didn't edit the map at all, other than naming all of these ranges. So I named them _1, _2, up until _31. So you can't just put a number there, and you can't put like a singular letter and a number there, but you can put an underscore and then or a character and a number. So that gave me the ability to reference to it with the indirect formula. So what I did was I could just do a sum product, and I just did an indirect of each of those. So if I just open up this formula, not that one, it's not a formula. So basically, I was just referring to, so H57 would be the neighborhood number, and I put the underscore there with an ampersand so that it concatenates the character and the number. And then I would basically just refer to the neighborhood like that. And I counted that against the icons, and I returned, in this case, just the values from the morning column. So if I just scroll up a bit, these are the icons, and those are the morning column, or that's the morning column. So the setup also took me, it was also quite quick, and I mean, it's just going like that and typing it in, enter, like that, typing it in, enter. So I think it's a very similar sort of speed that you can do it, as opposed to what you did. I think it's very similar, but I like the setup because that opened up the rest of the levels for me completely, and it made it very easy for me to do the rest of the levels. So level 3 to 5, I did with the same formula consistently throughout. So I used the sum product concept throughout, because it's nice because it basically gives me the count of each of the buildings, and then all the kinds of the icons, and I multiply it by the values, the corresponding values. So the only sort of nuance that level 3 to 5 introduced was not just referring to morning period, but also the other periods, and with that I could just index the full range. So that was sort of my setup. So I was quite proud of my setup when I did it, because it worked like a charm. But I also thought that the methodology that you followed, Jason, I thought there might be another way where we can, for instance, if you copy your map and you remove all the icons, right? I was also thinking of the find and replace principle, where you can find and replace. I think you can just go select a cell and then go. Oh no, sorry. You select your range first, and then you go find and replace, and you go choose your format, and you basically say where you choose the format from a cell, and you choose a cell, right? And then you replace it with something. Just go 1, for instance, replace all. So I was thinking whether there's maybe a formula where you could do like a row/column reference and be like, if the top, so sort of make it a circular reference, but if the cell above, or the cell to the right, or the cell to the left, or the cell to the bottom of my current cell is not selected, or if it's blank in essence, increment. But then I thought, well, how do you increment it to the left or to the right, and then down, and then to the right, and then down? So building a formula like that might have taken me longer than just going manually, and like you said, manually go 2, control enter, 3, control enter, 4, control enter, right? So like you said,
Yeah.
sometimes you don't want to be too clever. You just make it work, right?
Yeah, Renier,
Sorry,
I think
Steyn.
your idea can work. I'm just not. I wouldn't try it during a live or a session where I'm time
Not for the
limited.
first time, yeah. Not for the first time. If you've done it before, maybe try it. But if you thought of it for the first time, I think it. So I'm sure Dim or Bo would have interesting methods to do this. But again, the manual, quick and dirty method in these cases sometimes is what's necessary. I'll give the share back to you, Jason.
Yeah, thanks. And yeah, I agree with you 100%. The important point for me is, you know, the way that I like to think about these competitions is, a lot of it comes down to exam technique, and the exam technique that you are comfortable with. So there's no doubt that if you know the formula out of your head to increment with iterative calculations and whatever, you could write that really quickly if you know it. If you don't know it, you can spend half an hour trying to figure it out and score no points. But the value to me is attempting the case, figuring out that you don't know how to do something, accepting that, moving on, doing it manually, hacking it, and then going to compare what other people have done with the context that now you know what the challenge was.
Spot on.
And there's a huge amount of learning, because you've in the moment you've realized, okay, I don't know how to do this, as opposed to just blindly watching someone's video
Yeah.
and not having attempted the case. You don't appreciate the subtle genius of some of the things that people are doing, right? And so yeah, anyway, I always come back to this mentality of, attempting this stuff, taking on board that you don't know how to do something, and then figuring out or going to learn how other people do it. That to me is a phenomenal way to learn.
Yeah, and like you said, for example, the lambdas and the reduce and the scan the other day, where you just sat and you try to figure it out. I did the same. I went after you did that. I went and I did the same. And I watched another demo video where he used reduce and scan, and it was so simple because I had understood it and I had figured it out. It was so simple. So then I thought, well, I need to make a YouTube video where I explain how simple reduce and scan can be if you take it back to ground principles. So the same applies. None of these formulas are really, truly very intricate. They are, if you break them up and you understand them properly, they're all understandable. Sorry, you
Yeah.
can continue.
Yeah, cool. So I'm really keen to see how you guys tackled level 3 because yeah, for this one I sort of potted around a bit and came up with, I just sort of landed on populating the possible outputs for all the neighborhoods across any day any time of the day, with load shedding on and off for the schools kind of thing. Anyway, so level 3 asked us, that the schools and hospitals be excluded from load reduction. And so the way that I thought about this was to change this table where we have the input consumptions and make the schools and hospitals section a lookup, rather like a dynamic lookup rather than a static input cell. And so basically when how does this work? When the power is on, this is the amount of energy that's being consumed. And when the power is off, this is the amount of energy that's being shed. Now, I'm thinking about this in reverse, right? Because a lot of the questions were how much power do you shed during load shedding? And so, if you're a residential house in the morning and there's load shedding, you shed 800, whatever this is, watts, or I don't know, forget what it is, watt hours. Whereas if you're a hospital or a school, then during load shedding, you shed 0. So that was the way that I thought about it. But, I appreciate that can look like it's a bit backwards. But really, I had a switch here to say, if load shedding is on, or if the power is on, how much do they consume? And then I had a separate table if it's off. And I had 2 sort of basic inputs, what time of the day is it? And then what neighborhood are you in? And then I did this, pull the consumption for the neighborhood. And then I just ran a data table for all 31 neighborhoods across all times of the day. So this is my row input cell linking to this input over here. This is my column input cell linking to the neighborhood. And this is my calculation of the consumption for the neighborhood at that point in time, driven by these 2 inputs, and basically just populated a big data table of the consumption with load shedding on and off for all neighborhoods and all times of the day. And once I'd sort of got to that point, then figuring out level 3 was fairly easy. And then talking about what is the reduction in energy saving from shedding the following neighborhoods, I was then able to say, well, the difference between shedding the same neighborhood at the same time of the day, but with the schools and hospitals on or off, I just took the one value, subtracted the other value, and that gave me the answers for level 3. But I must admit, I spent some time getting to this point, and initially trying to be a bit more sophisticated about the solution, and eventually just said, listen, I'm just going to populate the data set here. It's not a huge number of it's not a huge number of values. It's 124 values, 31 times 4. And I needed to do it for load shedding on and off, or the schools on and off, I think. And then use that from there. So that, again, I think, a bit more of a hack approach from my side on this one, but ended up working well to have those data sets output.
Yeah, so I did it a little bit differently. I just want to show. So I firstly named a couple of the ranges, as I always do. So I've got icons, like I said, which were those little icons. Then I've got map, which we've discussed. Then I had normal consumption and I had reduced consumption. And essentially all I did was I copied the exact same table to the right, and I removed I made all the schools and hospitals zeros. And then I said periods. So that's periods of the day. So that's just morning, afternoon, evening, night. So that was my sort of initial setup. And then what I did was I wrote this little let formula, which is quite magical once I had it. And essentially all I did was I took the same principle from the previous formulas, where I did the sum product of the count of the area or the neighborhood against the icons, and I multiplied it by either reduced or normal consumption. And to find out which values I need to multiply it with, I used the let to just say my reduced values is the index of my complete reduced consumption sort of table and I indexed it for where it matched morning, afternoon, evening, or night. So it basically gave me back just the column of data which matches the icons, and I multiplied that with one another with a count of the icons. So that's as complex and as simple as it was. So that gave me the reduced values, and I just multiplied it, and that was essentially how I got to the answer. So I never used the data table for this case. I could have, and I like the fact that you did, Jason. But what was nice for me was this logic I could apply in level 4, same logic. Now it's just across the neighborhoods. And in level 5, essentially, I used the same, but I just split them out just to make it more logical. But yeah, let me not get ahead of myself. But yes, that little let formula was nice, and the fact that I could type it out like that made it easy for me to sort of error check, error handle, and write it quickly, and not have a lot of information that doesn't make sense. So that's how I did it. Steyn, did you follow a different approach?
A little bit different. Let me share my screen.
Cool.
Okay, so I also followed Jason's approach where I have the three maps. One is the original map that I like to leave untouched. Another where I have the VLOOKUP of the symbol of the one. And then the third map with the neighborhoods. So on the second map, I do a VLOOKUP of the symbol, but I use not one of the columns here. I use like a general column. And in this column, I have a offset formula. So if the value here is 1, then it uses the morning. If I 2, then it offsets with 2, and then it uses that one. And then that allowed me then to run a data table for all 8 scenarios at once. And then it was just a matter of doing an index match for the values, depending on do I want it for level 3 or later for level 4s and stuff.
Oh, that's cool. I like that. So that means you never had to adapt it really. You just sort of feed the parameters in, and it's a little program, a little computer program you write.
Yes.
I like it. Very cool. Okay.
Yes, so
so you want to cover level 4?
Yes. So in level 4, it was basically the same, just for my neighborhood, I just did a text split. So instead of just finding one neighborhood and summing it in my index, I did a text split so that it summed all of the values from this table. So it will find the morning, and then it will find the neighborhoods I added, and then add them together and give me my total. So that was quite nice for me.
Steyn, I'm amazed that you can do that in one formula.
It makes me a bit uncomfortable, to be honest. Let me just share what I did there. So like I said, I also used the text split. I just used the double dash or the double negative to make them numbers immediately, because as soon as I copied this across, I started doing this in most of the cases where you have to sort of keep to a structure. You've got 5 neighborhoods. I want to know when I run out of 5 columns. So I sort of create the sequence, and then give it a little block around it. And then when I did the text split initially without the double negatives, they were all left aligned, and that made me realized that they were text, and that's when I immediately, before I even applied my larger formula to it, I put the double negatives there, and then I basically just did this exact same formula from the previous one. So now I just referred to night and neighborhood, or period and neighborhood, and then just copied this formula across. And because I used count if, I couldn't apply it across all the neighborhoods. That actually errors out. So sometimes you have to go simpler, and you want to do dynamic arrays, but sometimes dynamic arrays aren't applicable yet. And Dermot's done a whole sort of video on that, where he talks about all the nuances of dynamic arrays and what needs to be fixed. So, but yeah, that's essentially all I did. And then basically the answer is just the sum of the 5 columns. So that was level 4. And then level 5, I just did a sum if back to my schedule. And I just basically did a sum if, sorry, that's formula text again. Did a sum if column A in the schedule is my neighborhood. So all I did was I took the exact same schedule that Steyn gave us, but now in question 5, the question is, what is the power consumption of the city over 10 days? So day 11 is given as an example, and then day 1 to 10 is what you need to calculate. And essentially, if a neighborhood was without power, the power consumption during the next period is 10% higher than normal for that period, except for the morning on day 1. So that's something that this was a freebie, but essentially it is not as complex as it sounds. So all I did was I calculated total consumption. Like I said, same formula as the previous ones, exactly the same formula. All I did was I calculated normal consumption on normal values, and they fed normal values in so that it feeds hospitals and schools as well, because schools and hospitals do consume power. So that's a mistake that someone could have made, is not including schools and hospitals in the total consumption before load shedding. And then the shedding formula, exactly the same formula again. So I was just referring to morning and neighborhood, and calculated load shedding across. And then the next period, the increase in consumption, the 10%, again, the exact same formula. But all I did was I took the reduced values, multiplied by 10%. And all I did was I was referring in the afternoon. So I was referring in the afternoon to the previous periods. And then it's just basically aggregation. So all I then did was I said, well, take total consumption less load shedding plus your next period's increased consumption. And then do a sum if, like I said on the main screen, of saying, well, if this is 1, then sum those, essentially. And that would give you the 2.668202. Okay, so probably summed up the wrong stuff now, but I guess you get the gist. I don't know what I did now. Oh, I added these ones as well. So rookie mistake. But anyways, so that is my my solution to this specific case. So yeah, that was level 5. I don't know if you guys want to share if you did something else on level 5.
No, I did the same, except I didn't have to use 5 columns for a neighborhood. I just used my formula, which had it in a single column.
Good. Yeah, that's nice.
Renier, before you go to the bonus questions, I'm going to throw myself under the bus here and just show you what I did.
Okay.
And just you know, the power of simplifying things as you've done, you know, is amazing. And you know, I guess in the moment you know, you kind of just make a judgment call, and you go with what you think makes sense. But I basically tried to calculate the power per per neighborhood for all 31 neighborhoods, and then if the neighborhood came up in this row, then take the reduced consumption, but build in the hospitals and the schools, and then
Wow.
if it was in the previous row, then add 10%. And so I ended up with this monster of a horrific formula. And I mean, the way that you guys have done this is so simple. Just take the normal consumption, take the reduced consumption, add 10% to the previous ones, and just sum them up. And flip. This was such a nightmare to debug this thing. There's no way I would have done this in 30 minutes, right? I remember testing this case and thinking, oh my goodness, this is such a hack. But yeah, just funny in the moment you say, okay, well, you overcomplicate things in your mind, and just learning to try and just simplify things down, right? Anyway, I was laughing at my solution watching yours.
Well, I like the fact that you threw yourself under the bus. It's like watching woodworking videos on YouTube, and the guy shows the mistakes he makes. That just shows you're human, right? I mean, that's what I like about Dim as well. He actually said, I think it was, I don't know if it was, yeah, it was a rugby World Cup case, the level 1 question. He built this monster. He just could have used a left.
Equals left one or whatever.
Yeah. So sometimes you sort of get stuck in the moment and you over-engineer it. And I think what I've found as well is if I don't work under pressure, I come up with these wonderful, neat methods of doing things. But when I'm under pressure, I flip and over-engineer because I don't read it properly. I don't understand it. The 10% throws me completely. I start panicking. I'm like, I've got 5 minutes left, and I start building a table like you did there. And then afterwards you say it's the most difficult case I've ever seen, but there's a simple answer sometimes. So yeah. So just around the bonuses, if I could just share what I did around the bonuses, I created a little extra sheet for the bonuses just because I was getting some clutter. Question 1 was, which neighborhood contains the highest number of or the most residential properties? And essentially what I did was I just did a sequence of 31 and then did a count if of my trustee indirect, and then I copied my little residential house across to this case as well, and I just did a count of that. And then we discussed this before we started recording now, but I tend to jump into max ifs every flipping time. I don't know why, but it's so much simpler with an X lookup. So the max ifs is basically it's stupid. There's probably a much easier way of doing it, but I'm just saying, give me the max of this number if this number is equal to the maximum. And that basically, so that doesn't necessarily work like it should. It'll only work if you only have one that matches. And in this case, it was 12, it was 19, and there were no other 19s. I guess XLOOKUP will also not necessarily give you the right right answer if you've got two 19s in there. And I'm sure DIM has a much simpler method of doing this, but I use the max ifs on this. But I just wanted to show the XLOOKUP is so much simpler. So with XLOOKUP, you could just say, give me, and let's do this one in an XLOOKUP. So I just go XLOOKUP. So look up for me a number that I know is not there. So I could just go 99 because I know there's only 31. And my lookup array is essentially, oh, sorry, yeah, that's not the case, but I need to say, well, I need to look up 99 in there. I know none of them is higher than 20, for instance. So I just do that. And then I say, return for me this array, right? And in that case, the match mode is exact match or next smaller item. So it's going to look for a 99, but it won't find a 99. The next smaller item will be 19, and it will return 12. And it's as simple as that. So much better than max ifs, and you won't struggle to sort of build that. You can easily fail with the max ifs because you can see it's a longer formula. can easily confuse. But an XLOOKUP is much simpler. We actually said before we started recording, I think XLOOKUP replaces the need for so many other formulas, because you can essentially do a sum ifs, a sum if, a count if, and a lookup, an H lookup, a V lookup, a max ifs, a min ifs, all with X lookup these days. So like I said, there's still cases where you want to use the older formulas, but X lookup is just magical. So that's basically what I did for the number of residential properties.
Yeah, so what
And
I
then-
did there
Yeah,
is I
sorry,
just
go.
used the match formula. So I matched the max value of the array. So since
Even simpler.
of the place of the neighborhood in the array was the same as the neighborhood number, I didn't need to look up the number. I could just use the results
Right.
from the match formula.
Yeah. So you just said max. So I don't use match anymore. I use X match for everything because again, it's like X lookup. And what I like about X match is you just need 2 parameters. Where with match you always need 3 parameters, which confused me. And sometimes I forget about that last parameter, and it completely throws my formula. So yeah, you basically just did the X match, or the match of the max of all of those. In this range, right?
Yes.
Yeah. So the same range. So that also gives you the right answer. Yeah. That's cool. And then yeah, always when I see a duplicate reference to the same range, I always think of let. So in this case, you didn't need a let because you were working under time and stuff as well, under time pressure. But let's say you had to refer to bonus C4 to C34 again, then it makes sense to use a let. Just a tip. So yeah, which neighborhood receives the most nighttime load shedding on the 11-day schedule? So what I did there was I basically just I just did so I did a sum if the just see if I split this out. So yeah, I was just referring to night and to the neighborhood. So I was doing an if across the full schedule. And I said where it matches, where the column B matches the neighborhood, and where schedule, oh yeah, sorry, the other way around. But anyways, so I could refer to the full schedule, and then I multiplied them with one another, and that would return for me a sort of array of trues. And then I could just do a sum of, if it's true, make it a 1. So I could just return the sum of, and it gave me the number of each of those. So that helps, because you can't do a count if on a range like that. So you would have to unwrap it.
Well, yeah. So what I did is I did a filter to filter it for night, and then I did a text join to get it into a single range, and or a single string, and then I just did a text split then I had a single range with the neighborhoods.
Okay, that also sounds hacky, but yeah. And then the same principle applies after that. You just sort of do either the match of the max, or you do the max ifs, or you do the X lookup of the exact or next smaller item, and you'll get number 17 back. And then yeah, for bonus 3, I initially looked at the case and I was like, I can see that afternoon the consumption is the highest, and night the consumption is the lowest. But then I was like, maybe Steyn worked something sneaky in there that would cause one of them to potentially not be the case. So I just didn't want to say deduct night from afternoon, because the question is which neighborhood has the largest decrease between the period of the highest consumption versus the lowest consumption. So all I did was, in the bonus, I said, well, again, use my trusty let formula, give me the normal consumption for that neighborhood, for that period. and I just used the trusty lock. So with this one, I locked the rows, but not the columns. And with this one, I locked the columns, but not the rows. So then I can pull my formula across and down. And then I just did, give me the difference between the max and the min. And with that, then I had all the values. And again, I could just do my X match of max, or my X lookup, or my max ifs. And those were the bonus questions. So again, the bonus questions you could have done at least 1 and 2 without needing to do levels 3 to 5. And again, you could have gotten quite a lot of quite a lot of points there. And I think a lot of our finalists actually followed that methodology as well, because I saw a lot more bonus questions being answered in this final than in the sort of prelim rounds, if I can call it that. You guys want to add anything to the bonus questions? Any clever techniques that you've used there?
Well, I had my data table, so it was just a simple matter of doing a max less the min for each neighborhood.
Yeah, cool. Yeah. So in essence, your method required a little bit more setup, but in the end, you could answer a lot more questions with it without needing to copy formulas across. I think I liked my lets, but my lets I had to sort of copy across every time, and I had to make small adjustments to it every time. Where if you have a data table, you can actually answer the whole case within one sheet, and that's essentially what we did in the previous case as well. But then, I mean, if we look at the final case, the grand finale case, I don't think there was a case there for a data table. According to me, it was essentially, once you've got your data structured, it was mostly just sum ifs, and you could solve it, or pivot tables even. I actually solved a lot of them with pivot tables. So sometimes a data table is the way to go. Other times not. I mean, we've seen that Dim has sort of steered away from data tables. He just builds lambdas now. It seems he just goes and writes lets and lambdas with scan and reduce and map and all kinds of things as well. So yeah, I think you, like you said, Jason, you find your stride in your exam technique, and you find what works for you, and you run with that. So, but yeah, Peter Pino actually did well in this case. I think he won this case, or this round. Did really well, and I know that he did practice with one of these map rounds. So he was expecting one. So yeah. Any closing thoughts, arguments from you guys?
No, I mean, it's just a cool case. Thanks, Steyn. I enjoyed it. And again, very sort of different kind of case, right? And problem solving that you had to sort of apply on the fly. So yeah, really cool. Thanks.
Yeah, and setting up the case made me just realize how much time sometimes go into these cases to set it up, and then you need to do it within 30 minutes, and then people are done with it.
Because I told Steyn I want a case with load shedding, and he was like, he's got ideas, and he started running with it. And like a week or two later, I'm like, okay, Steyn, how's it going? He's like, oh, still busy. It's like, so I mean, with snakes and ladders, I could turn it around in like 24 hours. But if you build something like this, there's a lot more that goes into it, especially if you want to make it realistic as well. And knowing Steyn, I think the consumption would probably be realistic in comparison and stuff as well. So trying to actually make it as close as possible to real world. But
No, I don't think
looking,
it's sort of realistic in the sense that a factory uses often more than a house, but I don't
not
think
in
it's,
comparison. Okay.
Yeah.
Gotcha.
And also interesting to note, this map originally had 60 neighborhoods, but then we decided it was probably too much, and then we reduced it.
Yeah. Yeah, the first time we tested the case, there was 60 neighborhoods, and the setup was just too much. It just took too long. Yeah.
Yeah, that's where you find the balance between manual versus formula driven, right? 31, type in 600, formula.
Yeah, definitely. Okay, thanks guys. We'll catch up again soon, and thanks again for the late nights, and thanks for the assistance. Thanks, Steyn, for the interesting case, and we'll try and find some time between all the exciting rugby games lined up for the weekend and stuff as well, because I'm gonna try and watch every single one of them like a child. Um, and yeah, then we'll record case number 3, which is my final case called the Mzansi Hotel Group, which was a case for Power Query, and I'd like to see how you guys attempted it as well, and I'd like to show my solution. And like I said to the guys, if you know Power Query well, I think you can actually solve that case in like 10-15 minutes, because the setup can actually go really quickly. But yeah, we'll tackle that one as soon as we have a chance. Thanks guys, you have a nice evening, and we'll chat soon.
Good night.